All right, greetings everyone. Welcome to the third part of the video for section 7.2. So continuing on, we're going to learn a new identity and how to use it. Okay, so this identity allows us to rewrite the sum of a sine and a cosine as a single sign. And let's first of all read this. So it says to rewrite something of the form m times sine of bx plus n times cosine of bx in a form where it's a times sine of bx plus c. And so notice basically what we have here is a sine and a cosine term being added together where they're not being squared, neither term is being squared, and on the inside of the sine and cosine they have the same coefficient of the variable. So an example of something like this could be, say, -2 times sine of 3x plus 7 times cosine of 3x. So that's an example of something we can rewrite in this form as a single sine function. Now this will not work if it was, say, something like -2 times sine of 3x plus 7 times cosine of 5x. So this will not work because notice what's inside the sine and the cosine are not the same. Nor would it work if it was something like, say, -2 sine squared of 3x plus 7 times cosine of 3x. So notice here now, the sine is being squared, which is not part of the identity. Okay? All right, so this tells us that if we have that form, though, again, the sine plus the cosine, where the thing inside of each of them is the same, we can rewrite it as a single sine function, so a times sine of bx plus c, where the value a is given from this kind of Pythagorean theorem type formula. So a squared equals m squared plus n squared, which again, notice the m's and the n's come from up here. And then we can find the value of c by noting that the cosine of c is given by the ratio m over a, and the sine of c is given by the ratio n over c. And I'll say that in this case, we need to set up both of those ratios in order to find the value of c, and I'll talk more about why that is. All right, so let's use this identity here on this slide. So we have 3 times sine of 2x minus 5 times cosine of 2x, and we have to rewrite that in the form a times sine of 2x plus c. And we can hopefully see that this does follow that pattern we just saw. So the m times sine of bx plus n times cosine of bx. Okay. And so notice again that what's on the inside of each of these things is the same, so that tells us it does follow our pattern. So we can start by finding the value for a. And so we'll use that a squared equals m squared plus n squared. So our value for m is 3. Our value for n is -5. If we work this out, we'll have a squared equal, let's see, 3 squared is 9, -5 squared is positive 25, because -5 times -5 is positive 25. We have a squared equals 34. We solve by taking the square root on both sides. In this case, we're only going to worry about the positive value for a, so I'm not worried about the negative version. And so this will tell us then that a equals positive root 34. Okay, so there's our value for a. And now we need to find the value for c. And again, we had those two ratios for both sine and cosine. We're going to set them both up. So from the notes we had, the cosine of the angle, or cosine of c, is given by the ratio m over a. So that would be our value for m is 3 over the value for a is square root of 34. And then to find the sine of c, that ratio is n over a. So in this case, that would be the -5 over square root of 34. And then here's the reason why we set up both ratios. Is because we need to figure out what quadrant the value of c should be in. And so notice what we have here is a sine ratio, or excuse me, a cosine ratio that's equal to a positive number, a sine ratio that is negative. And if we think about on our unit circle or in our quadrants where cosine is positive and sine is negative, well, that'll be in the fourth quadrant. So we need to make sure that whatever we get for the value of c needs to be in the fourth quadrant. Okay, from here we can find the value of c by using inverses in our calculators, and we can do either inverse sine or inverse cosine. I'm going to do inverse cosine. So I'll do inverse cosine of 3 over square root of 34. And when I do that, I get 1.0304. But notice I took the inverse cosine of a positive number, right? And we know that inverse cosine only gives us answers in the first or the second quadrant. And so since this is positive, I know this 1.0304 is actually in the first quadrant. This part here is actually not true. This is not the value for c then. But I can use that to find my value for c because I know that'll be my reference angle in the fourth quadrant. It's 1.0304. So to find the angle in the fourth quadrant then and the value for c, using that reference angle, I could do 2 pi minus that 1.0304. Okay, and when I do that, I end up with the value for c being 5.2528. And so therefore we know that our sine, or our form that is a times sine of 2x plus c. Sorry, I'm going to have to clear all this out. So the value for a was root 34 times sine of 2x, and then our value for c was 5.2528. Okay. So that gives us this answer here. So we know that 3 times sine of 2x minus 5 times cosine of 2x can be rewritten in the form root 34 times sine of 2x plus 5.2528. Okay. Let's use this now to solve an equation. So here we've asked to solve 3 times sine of 2x minus 5 times cosine of 2x equals 3. This may kind of look like one of the sum or difference identities we had before, but it's not. Okay, from the first couple of videos, that won't work. But it is what we just had. Actually, it's the exact expression we just had on the previous slide. And so we know that can be rewritten as root 34 times sine of 2x plus 5.2528 equals 3. And now we can solve this, okay, for our first 3 positive solutions. So we'll divide by root 34, divide by square root of 34. These will cancel. We now have sine of 2x plus 5.2528 equals 3 over square root of 34. I'm going to now use u substitution. So let's say u equals 2x plus 5.2528. So now this becomes sine, sine of u equals 3 over square root of 34. So then we know we can use inverse here to help us find our answers. Now, I'm not going to go through all the specifics of this because we've done this before, but note that we're taking the inverse sine of a positive ratio, which tells us we should get answers in both the first and the second quadrants. So I'm going to find those answers. So I get 0.5404 is my answer in the first quadrant. Can use that to help me find my answer in the second quadrant, which is 2.6011. 012, excuse me. And then we need at least 3 positive solutions, it says up here, so we'll keep going. So I'll do 2 pi plus that inverse sine, or that first answer I got, which is 6.8236. And then for answers that, for reasons, excuse me, that'll become clear here in a few minutes, I'm actually going to find 2 more answers. So I'm going to do this. 8.8844, and then 13.1068. Okay, so I ended up with 5 answers there, and I know we only need 3. But again, in a second, hopefully it'll become obvious why I did that. So notice these are all values for u, but we're not solving for u, right? We're solving for x. So we need to use this equality up here that u equals all of these things. And in that case, we're actually going to set up 5 different equations. Okay, and I won't set up all 5, just again for the sake of room and time. But so we'd have u equals 2x plus 5.2528. But all the values we have for u are 0.5404, 2.6012, 6.8236, 8.8844, and 13.1068. And we would solve 5 different equations, or we'd set 2x plus 5.258 equal to each of those things and solve for x. And again, I'm not going to go through all the specifics of that here on the PowerPoint. I'm going to do these on my calculator. And when I do that, I get negative 2.3562. Then negative 1.3258. Then 0.7854. $1.8158. And 3.927. Okay, and again, that's just taking each of the yellow angles there, setting them equal to 2x plus 5.2528 and solving for x. Now, hopefully from this, you see why I actually found 5 solutions to begin with. Because we're asked to find the first 3 positive solutions, but notice my first 2 solutions actually ended up being negative, so those don't count. But my next 3 were all positive, so these 3 would be our answers. 0.7854, 1.8158, and 3.927. Okay? All right, this might be a video you'll want to go back and watch again to make sure you got all the details. Thank you for your attention.